Well, hello everyone. I am Michael Offiero. I am happy to be back for another winter of doing these weather videos. As most of you who watched my videos last winter know, I wasn't really successful with predicting the snow, and we're gonna try and be better with that this winter. Number one, I'm not gonna look at the long term and get really excited about possible snowstorms anymore, because we all know that leads to a wrong prediction, and then everybody gets upset because it doesn't go the way they want. So the basic idea is there's going to be variation in the models up until very close until the actual event. So I'm going to try to just point out threats rather than say that there's going to be a big snowstorm here. I'm just going to say this is a possible threat. So looking forward to another winter of doing this, starting pretty early in November. Yes, it's already pretty cold outside. And believe it or not, there are a couple of threats that I am watching. From now until about Thanksgiving, there are 3 different systems that I'm watching on the models. Right now we're looking at the American model, and I just want to very quickly go over these maps again. The one on the top left here that you see, that is the vorticity map, basically at 500 millibars, so that's up in the upper levels of the atmosphere. These red areas are just basically areas of spin that provide energy for storms to form. So wherever you see concentrated areas of darker red, we call that a shortwave trough in most cases. In other cases it could be a long wave, it's very wide. But most of our disturbances, like this is definitely a shortwave trough over here. It's not really organized yet, but there's dark red in here, and this is part of the first disturbance that I'm going to be talking about. And this over here, this dark red over here is more shortwave energy that moved through. That was what created the rain last night and brief period of snow very early this morning. So that's the basic idea. This map is basically low and high pressure. So where you have areas of low pressure, in general, those are going to be out ahead of the areas of vorticity here, because what happens is when you have this vorticity, you get spin and upward motion out ahead of it, so that's where your storm gets created, and that's why your low pressure is always out ahead. So you always have your storms are indicated by the low pressure, and high pressure is generally dry and sunny weather. Okay. Going down here, I'm only going to use the bottom right map because I still have yet to figure out what the bottom left map means, to be perfectly honest. But for the forecast that I'm doing, these 3 are the only ones that are necessary, pretty much. When I do figure out what the bottom left map is, I will probably use it, but for now we're going to focus on the 3 that I'm going over. This is your precipitation map. So the basic idea here is these are connected because you have trough over here, shortwave energy there, low pressure out ahead of it, and then with that low pressure you have precipitation, so you have a storm forming. So that's how those 3 maps are connected. And then obviously you can see where you have areas of high pressure here, there is dryness, there is no precipitation. So that's the basic idea of how I use these models to look at potential storm threats. So I look at the trough, the shortwave energy, I look at how it's oriented, and I look at the model and kind of predict where it's going to go. And basically based on the location of low pressure, for us it's really important, the location, because if it's close to the coast or if it passes west of us, then you have a flow from the southwest coming up, so the northeast flow there, and that brings in warmer air from the Gulf and the ocean, and we would get more rain than snow. But if the low pressure is off the coast more, out towards Cape Cod or a little bit further east, if that's where it passes, then you have winds bringing in colder air from the north, and that would be conducive to snow. And also you would usually have a high pressure over here funneling in cold air as well, so that would be conducive to snow. So that's the importance of the location of the low pressure. And basically when you have a trough like this, you want it to go south, and you want it to dig so that the orientation of the jet stream becomes sharper, and if it's all the way down here, it'll be pulled up the coast like this, like so. You don't want it to be too close, but it'll come up the coast. If this trough digs further south, this becomes sharper and it comes up. And the problem with the first disturbance that we're going to talk about is that it does not dig south. So this is the first piece of energy. It's not the primary piece. This is the first piece of energy we're looking at. A second piece of energy is going to come down and kind of direct this piece to the north and east. So this is Saturday right now. And the first set that we're talking about is for Sunday night into early Tuesday, basically. So here we go. It's going to move to the east. Notice how the orientation of the jet stream doesn't really pull it too far to the south. Basically, alright, now we're on Sunday night. So this is our first piece of energy here. And then this is the second piece of energy coming in behind it. This is the main trough, the main shortwave trough. You can kind of see how up here you have a circle over here. That means that this area of low pressure here, which is associated with this shortwave trough, is cut off. So that allows it to strengthen and enhance precipitation over that area where it is. But basically this piece of energy here is going to direct this piece of energy, and notice that this energy here is not south. If it was further south, then this jet stream would be a little more oriented in such a way that it would come down here. So this narrow trough would be further east if it comes down further south, and thus these isobars that are going to the northeast would also be further east, and this would come up the coast. But as you can see here, that doesn't happen. So now we're on Monday, okay? And so notice also the tilt of the trough is always very important, because if it's positively tilted, then that means the energy will generally move to the east, not to the northeast. Also, it's important because if this is negatively tilted, which is in this direction, it pulls in moisture from the ocean, which enhances precipitation. But we are on Monday right now, so notice how, because this isn't farther to the south, this jet stream is oriented in such a way that if you have low pressure out ahead of it, which you do, right here, this is during the day on Monday. Look, we have all this precipitation over us right now. And basically to the west of that, this is all snow or wintry mix. I-95 on north and west. But if you notice here, remember how I said the position of this low pressure system is really important because it's right over us. And the reason for that is, look at the orientation of these isobars here. If you have low pressure here, it's going to go up this way to the west of us, and that's what's happening here. If this was further south, you would want this to come further southeast so that the low is pushed further east, and then the trough is still narrow, so it comes up the coast just a little further east, and then you get a big snowstorm because you would have cold air funneling in on the western side. But because this low pressure is close to the coast, you have that northeast flow, or southwest flow. I'm still confused about how that works, but the winds are coming from the southwest, so you get warm air being ushered in, and thus all this precipitation that you see, that's I-95 east, New York City, Long Island, which is important for us, it's all rain. It's not snow. So the Monday into Monday night event is going to be rain. How much rain? Thinking about a half an inch to an inch of rain, maybe. I mean, it could be a little bit more, but it's your basic rainstorm, you know, up to the north and west. After this trough, this is where we were. As we head into Monday night now, this is where we are on Monday night. This is starting to become negatively tilted, so that's going to be important for when it gets up here into Maine and southwestern Canada there. So this storm begins to move to the north and east because of the negative tilt. But again, your low pressure, it's to the north of us now, and it's just not passing in the right area because you still have warm air coming in. It is getting colder though, because first of all, look at all this precipitation you have. Again, this is all rain because of the warm air being ushered in. This is Monday night now at about 7 p.m. On the back end of this though, you have an Arctic front that's going to be coming through, a cold front. So on the back end of this low pressure, you're going to have cold air coming on in, ushered in by these areas of high pressure. Now the question is, the only way we could get snow with this is if this cold air that's moving in quick behind this area of low pressure moves in quick enough and changes the rain to snow. That's the only way we will get snow, and it will be late Monday night into Tuesday morning if it does happen. So this is early Tuesday night still, so we're still not cold enough because this warm air is still kind of residing in our area. And this is tilted in that way. So then this is where we were. Oh, I'm sorry, no, it's not where we were. We were here. Okay, this is where we were. And now we're into early Tuesday morning. The precipitation is left. The cold air is now ushered in, though, and look, there's no precipitation. So it looks like it's going to be an all-rain event, basically. And the other models are basically showing the same thing, so I'm not really going to get into going into comparing the models here, because they all show the low pressure coming up the coast and passing either right over us or to the west, ushering in that warm air. There's not a single weather model that predicts snow with this system at all. All temperatures are above freezing. They're in the low 40s or upper 30s, and they don't bring in cold air quick enough behind this thing to allow for a change over to snow. So, is there a chance that it could happen? Yeah, there could be a brief period of snow, maybe early Tuesday morning if precipitation sticks around long enough, because you still have spin up behind the front from this vorticity max here. That's the only way. I don't think it's likely, but, something like this morning where we got a little bit of snow, if you were up for that. It was very brief. Other than that, that'll be an all-rain event. So, now, looking ahead, that was disturbance number 1. You have a cold front that's being dragged through our area by this system. Okay? So, on Tuesday, that front is dragged through, and behind it, we have cold air being ushered in. So we have high pressures coming down from the Arctic, from Canada, and you have all this cold air being ushered in. So in layman's terms, Tuesday into Thursday and into the weekend, we're going to be below normal temperatures. Highs will be in the mid to upper 30s on some days, as low as that. Other days it'll be in the low 40s. Like Wednesday is probably going to be the coldest day of the week because high pressure is closest to us on Wednesday, according to the GFS. So we'll have definitely a good funneling of cold air coming in on Wednesday. Then after that, you have another area of low pressure here on Thursday. That's not really going to bring us any precip, but it has another cold front attached to it. Okay, so on Friday, that cold front is going to move through. Alright, there it is. Now that cold front is over here. Right? So now, after you have a cold front move through, you look for pieces of energy to see if storms can form. Where was I? Sorry, I have to get used to doing this again. Alright, so this is where we were, and now you look for pieces of energy to form, and as you can see, we have a little bit of energy coming in right here and right here along the northern branch of the jet stream. And so with that, you have areas of low pressure forming, right? So when you have vorticity coming into a cold air mass, when it slams in there, you get the upward motion and you get storms to form. So I was at 150, right? So now what we're watching here is this piece of energy is going to combine with the southern part of this trough here, this vorticity, and you get a little bit of a storm to form. It's not even that big. It doesn't even register on the map here. Like, there's not even an area of low pressure. But if you look down here at the precipitation map, you can see that there's obviously precipitation forming. Right? So you have that precipitation forming. It actually goes all the way down to here because of energy over here. But we're going to focus on the upward part. And if you keep going ahead, we were right there, keep going ahead, this energy has consolidated and it's going to move to the east, and whenever you have vorticity like that, you get spin up ahead of it, you're going to get precipitation. And if you look here, you have high pressure, we had a cold front just move through, so we do have cold air in place on either side of this thing, on the left side and on the right side, and your trough is over here moving to the east. So what am I saying? I'm saying that on Saturday, because this is Saturday now, alright, there it is, this is our trough, and out ahead of it, if you look at your precipitation map, you have precipitation, right? And if you go to Weather Bell, which is a website by Joe Bastardi, for those of you who know him, that precipitation is in the form of snow. So this is Saturday morning. I showed you on the map here, this is also Saturday morning. You have precipitation moving in because of this piece of energy. It's basically a clipper system. Clipper system is basically pieces of energy that come down from Canada and they move through and they produce light snow. So if you look at this, I said it was cold enough because you had the cold front move through. This is going to be snow during the day on Saturday. So what I'm thinking for Saturday is you got a clipper system coming through, high pressure supplying the cold air. I'm thinking maybe if this does happen the way that it's showing on the models right now, it could be a couple inches of snow maybe, or just some snow showers. The GFS brings in about an inch or two from this for our area. Clipper systems typically don't bring heavy precipitation, so I'm not really expecting a big storm from this based on what the GFS is showing. Okay, so that might be, it could be a pretty good first accumulating snow event, maybe 1 to 2 inches if that does play out correctly. Now what I do want to show though is if you look at the Canadian model is something very different with the clipper system. Alright, if you look at, what am I looking at here? I'm looking at this, right? The Canadian model does something very different. It has pieces of energy. So if you remember on the GFS, this piece of energy just stayed by itself and went to the east. Okay, that's the difference. Okay, what the Canadian model does is it takes this piece of energy from the northern branch of the jet stream, southern piece of energy, it combines them. I'm way off here. Alright, so here we are. Sorry again, I apologize, still have to get used to this. Takes these two pieces of energy, combines them, and then moves them to the northeast. So not only do you have snow because of this northern part, but you also have another area of low pressure forming down here near Florida. Okay, near Florida, and that's going to move up the coast, and we get more precipitation because of that. So here on our precipitation map we have snow, what's supposed to be snow from the northern part of that, because we have cold air being provided by this high pressure and additional cold air out here over the plains, and that moves up the coast here. So now if you look, sorry, this is where we were. This is on Sunday. You have an area of low pressure there. It's not well defined, but you can kind of see you have precipitation remaining around. Now the GFS just pushed the clipper system out within the day on Saturday, but now you have more precipitation coming up, and whether or not that hits us is a question of where this low will go. This system doesn't really look very potent or strong to me. I'm not really sure how this is going to work out because we're still so far out, but something to watch, because if you do get this southern part combining with the northern part, you might have sort of like a 2 rounds of snow, or 1 round of snow and 1 round of snow and rain, depending on the track of this thing here. So that's threat number 2 to watch, either a clipper system or some sort of double event. And then the last event that I'm watching, really quickly, because this video is already 20 minutes long and I really didn't want to do that again. I wanted to keep these short, but because I can't stop talking, I just keep rambling on. here we go. We were at... This is Monday. Okay, so here we go. This is the Clipper/storm system moving out that's affecting us next weekend. We still have cold air in place. We have high pressure, so we still have cold air in place. So there's still room for another storm to form. Maybe bring some snow, or if this moves out quicker, then rain, or depending on the track of the low, rain. You have this piece of energy here. That's going to move south, and again, it just doesn't dig. You know, it's moving east, and then the orientation of this trough brings it right up to the west of us. And if you look, so again, this isn't really an impressive, it's not really a narrow trough, it's kind of wide. You don't really want the energy to look like that if you want a coastal storm. And so what happens is there's your low. Look at that, it's like over Pennsylvania. You want it to be out over the ocean. And this is on Tuesday. This is the Tuesday of Thanksgiving week. Okay, so then that moves to the north and east, and it affects us for a couple of days, actually. Okay, so the GFS does not bring this far enough south for it to dig and then come up the coast. Now, Canadian model, however, always has something to say. Really quick. Canadian model, just going straight to it, this energy on the GFS was all the way up here, over the central U.S. here. The Canadian model has it all the way down in the Gulf, and that's what you want for a snowstorm. So moving ahead here, look how far south it is, and look at the orientation. If you have a low out here, look where it's going to go. You have low pressure forming right down here, okay, in Georgia. And if you look at the orientation of this trough and the isobars, where's it going to go? It's going to go up the coast, okay. So that's what the Canadian model shows, and it's a week and a half out. So those are the three threats we're watching, and this would be anywhere from, and again, you do have precipitation coming up. That would be from Tuesday to Wednesday, Thanksgiving week, maybe into Thursday. So the three threats, again, I'm outlining Monday into Tuesday this upcoming week, which is going to be rain, most likely. Next weekend, either a Clipper system with a couple inches of snow, if that, maybe just some snow showers, or some sort of a storm system that the Canadian is showing, so that's next weekend. And then Thanksgiving week, anywhere from Tuesday to Thursday, is the next storm that we're watching, and we'll see what that goes. So, not really saying anything about these yet, they are just threats. The first one we know is rain, and then after that, the next two are just threats. Alright, so we'll update that. Thank you for watching this 23-minute video, which I really didn't want it to be this long, but, you know, really interested in this stuff, can't stop talking. So, we'll try to make the next one shorter. Alright, thank you.